For this question, we want to use the graph of y equals 2 to the x and transformations to sketch the exponential function f of x equals negative 2 to the x plus 2 minus 3. We want to determine the domain and range, determine the y-intercept, and find the equation of the horizontal asymptote. So we're going to start by taking a look at the graph of y equals 2 to the x. I'm going to graph this by plotting points, and I'm going to choose a standard set of x values, negative 2, negative 1, 0, 1, and 2. I'm going to substitute it into the equation 2 to the x, and that would give me 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the 1, and 2 to the 2. I'm going to start down here with the easy ones. 2 to the first power is 2, 2 to the second power is 4, 2 to the 0 power is 1, and when we have a negative in the exponent, that means that we're going to do the reciprocal of the base. The base is 2, and the reciprocal of 2 is 1/2. So the negative turns that into the reciprocal of the base, and then we raise it to the first power. So 1/2 to the first power is 1/2. We have 2 to the negative 2, so once again a negative exponent. We're going to do the reciprocal of the base and raise it to the second power. That gives 1/2 squared, which is 1/4. So this gives us a set of ordered pairs. And with those ordered pairs, we're going to be able to draw a sketch of our graph of 2 to the x. So our ordered pairs are negative 2 and 1/4, negative 1 1/2, 0, 1, 1, 2, and 2, 4. So let's plot these points and take a look at what the graph looks like. So we have negative 2 1/4, negative 1 1/2, 0, 1, 1, 2, and 2, 4. As we allow our x values to get larger, this part of the graph will get larger and larger, and so it's going to infinity, and on this part, the y values are going to get closer and closer to 0. And that's what it was referring to, having a horizontal asymptote. The horizontal asymptote is right on top of the x-axis, and it's the equation y equals 0. So we have a sketch of what our graph looks like. Y equals 2 to the x, and now we're going to focus on the function that we're interested in graphing by transformations. So let's write that function down. The function f of x equals negative 2 to the x plus 2 minus 3. And you can see that the variable is in the exponent with a base of 2. And so our base function is y equals 2 to the x, the one that we just graphed. So just a couple key points to keep in mind from what we learned about. A key point is this point right here. I think of that as sort of an anchor point, the ordered pair 0, 1. The fact that the graph goes to infinity on the right-hand side, so y is approaching infinity as x approaches infinity, and then on this end, y is approaching 0 as x is approaching negative infinity. So as just a quick sketch, I keep this in mind for the graph of y equals 2 to the x. So we want to look at what those transformations are. We have this negative, which is one transformation. We have a plus 2, which is another transformation. And we have a minus 3. It's another transformation. So these are going to affect the graph that we started with to get to that ending graph of f of x equals negative 2 to the x plus 2 minus 3. So that negative is a transformation called a reflection. Anytime we multiply by a negative, we get a reflection. Now there are two types of reflections. You can reflect horizontally, which is over the y-axis, or you can reflect vertically, which is over the x-axis. Because this negative is outside of the exponent, this is a vertical reflection. This plus 2 is in the category of a shift. It's going to shift, and there are a few subcategories of shifts. You can have horizontal and vertical shifts. That plus 2 is inside the exponent, making it a horizontal shift. And there are two types of horizontal shifts. You can shift left or you can shift right. Because we have a plus 2, that means it's going to shift to the left 2. If we had a minus 2, it would shift to the right 2. Then we have this transformation of minus 3. This is also a shift. Shifts occur when you're adding and subtracting onto your base function. So a shift, and once again, we can determine if it's a horizontal or vertical shift based on the location of that adding or subtracting. So this time the minus 3 is not in the exponent, it's outside of the exponent, and so this is a vertical shift. And vertical shifts, there are two types. You can shift up or down. This is a minus, so that means it is shifting down 3. So with these in mind, we're going to be able to draw a sketch of our f of x equals negative 2 to the x plus 3. So first thing I'm going to do is adjust the location of that horizontal asymptote. The only one of these transformations that affects that horizontal asymptote is shifting vertically down 3. So if we shift down 3, the new horizontal asymptote will be at y equals negative 3. The other transformations don't affect it because if you take a horizontal line and you try to shift it left or right, it's still the same horizontal line because the horizontal line is going forever in each direction. And a vertical reflection takes something that is above and reflects it below. Because the horizontal asymptote started off right on top of the x-axis, it's not above or below, so it's not going to change. So only the shift down 3 affects it. So then I want to think about what's happening to that anchor point that is at 0, 1. So that anchor point started off at 0, 1. It's going to get shifted left 2. Let me use my colors. So when it gets shifted left 2, it would go here. Then it's going to get reflected. So reflected is whatever's above gets moved to below. So right now I'm 1 above, I'll get reflected to 1 below. And then I'm going to shift down 3 from there. So 1, 2, 3 would put that point right here. So that anchor point moved to its new position at negative 2, negative 4. And the last thing I'm going to do is to draw a reflection of this graph right here. So remember we said on the right side we go to infinity. Well, the reflection is going to cause it to go to negative infinity. And on this side, the y is approaching 0, and the y will approach 0 again, but this time from below that horizontal asymptote. So we now have a sketch of the graph of -2 to the x plus 2 minus 3. Now there were a couple more questions that we need to answer related to this. So if you remember, we needed to know the domain and range. I can use my picture here to find the domain. Now this is an exponential function, and every exponential function has a domain of -infinity to infinity. We can verify that with our ruler. So the graph will start at -infinity and continue all the way to +infinity. For the range, we'll hold our ruler horizontally and go from bottom to top. So this arrow indicates that my y values start at -infinity, and they're going to continue until I get to that horizontal asymptote at -3. So my range is -infinity to -3. I'm putting a parenthesis on -3. It should not be included because you never reach that horizontal asymptote. We also need to determine the y-intercept. We can do that algebraically. So the way that we find a y-intercept is by letting x equal 0. So I'm going to substitute a 0 into my function. That's -2 to the 0 plus 2 minus 3. -2 to the 2 minus 3 is -4 minus 3, and that's -7. So I didn't do a great job with my sketch here, so it should be more like this. Crossing the y-axis at -7. So our y-intercept is the ordered pair 0, -7. And then the last question that was asked was about the horizontal asymptote. We already found that using the transformations, our horizontal asymptote is at y equals -3. Thank you for checking out my videos. Have a great day.